Hey guys, we're going to pick up where we left off before break. We are going to look at whenever we have ionic compounds that have transition metals. So far, we've only done ionic compounds with the representative elements. Transition metals are a little bit different because they can form cations that have different ionic charges. So we have to be able to know which charge we're dealing with at any point in time. The charges of the cations have to be found from the number of electrons lost um, because transition metals are able to lose electrons from multiple places whenever we look at their electron configurations, which is what gives them different charges. So for example, iron has two possible cations. It can be iron with a positive 2, where it lost 2 electrons, or it can be iron with a positive 3, where it lost 3 electrons. The naming method that most people are going to use for these is the stock system. This is going to have a Roman numeral in parentheses right after the element name for the metal to designate the charge of that metal. So the Fe plus 2 is going to be iron 2 ion, so it has the Roman numeral 2. And Fe plus 3 is going to be iron 3. So let's look at a couple simple ones. Just naming some transition metals. We have CO3 plus. CO is cobalt, and it's just going to be cobalt 3. Make sure that you are familiar with Roman numerals. I'd say up to 5. Um, Chromium's the same way. The Ni plus 2, Ni is nickel, and it's going to be nickel 2. Remember that most of those metals underneath the stair step can also be considered transition metals. So stuff like lead, tin that are under there will have multiple charges as well. Pb is lead, and it has a positive 4 charge. So it'll be lead 4, which is the IV. If you are not in honors, you can skip this part. But for honors, you also need to be able to name transition metals using the classical system as well. It is an older system of naming that uses the root of the name and then different suffixes to signify if it's the higher charge or the lower charge. So for transition metals that have multiple charges, you're going to use the root of the element name. You're going to be responsible for 5 classical ones, so 5 different elements. One of them is iron, which is symbol Fe, is from its Latin name ferrum. So the main part of that name is going to be the fer, the Ferr. It is either going to have a suffix or an ending of OUS or IC. The ending of OUS is used for naming the cation with the lower of the 2 charges. The ending of IC is used to name the cation with the larger of 2 charges. So iron 2 is going to be ferrous because it's the smaller charge. Iron 3 is going to be ferric because it's the larger charge. The bad thing with this is it only tells you if the charge is the larger one or the smaller one, but it doesn't tell you what the actual charge is. So you will need to know the charges for your 5 classical transition metals that you're assigned. So the first one we said was iron. Excuse me, let's look at our other ones. Our next one is going to be copper. Copper, remember, is Cu from its Latin name cuprum. So copper can have a charge of positive 1 or positive 2. Copper 1's the smaller charge. So this is going to be cuprous. Copper 2 is the larger charge. So this is going to be cupric. Gold, if you'll remember, is Au from its Latin aurum. Gold can have a +1 charge or a +3 charge. Excuse me. So gold with the charge of 1 is smaller. So this will be auric, or excuse me, RS. And gold with a +3 charge is going to be auric. Lead and tin can both have a +2 or +4 charge. Lead, if you'll remember, is Pb from its Latin name plumbum. So lead 2 is the smaller, so this will be plumbus. Whereas lead 4 is the larger charge. This will be plumbic. Tin is Sn from its Latin name stannum. So tin 2, the smaller charge, is going to be stannus. Oh, excuse me, my alignment's off. Tin with the +4 charge is going to be stannic. So those are the 5 that you're going to need to be able to use consistently. You can also name other things with the classical system, but it will use the root of their English name. So for example, mercury can be +2 or +1. Since +2 is the higher charge, that would be mercuric. Something like chromium, they can be +2 or +3. +2 is the smaller charge, so that would be chromus. And something like manganese, that can be 2 or 3. The 2 is the smaller one, so that would be manganese. Just to show you how that can be used with ones that are not the Latin names as well. Note that there are some transition metals that do not have a stock or a classical name because they only have one possible charge. So you have to know the charges of these 3 because you're not going to be given Roman numerals or anything like that. The first one is silver. It's always a +1 charge. Cadmium and zinc, which are in the same column, are always going to be a +2 charge. How I remember these, if you look on your periodic table and find aluminum, remember aluminum is +3. One row to the left is cadmium and zinc, so they're +2. Another row to the left is silver, which is going to be +1. So make sure that you remember those 3. And then looking at naming compounds with transition metals. So if you have a compound with a transition metal with more than one charge, you have to name it either using the stock system, so including those Roman numerals, or by using the classical system. The hardest part is figuring out which charge you have. So you always have to look at what that transition metal is attached to figure out its charge. For example, CuO. We know Cu is copper and O is oxygen. So it's copper oxide, but we don't know what the charge is. Since oxygen has a -2 charge, in order for them to have subscripts of 1, excuse me, copper has to be a +2 charge for them to cancel out. So this must be copper 2 oxide or cupric oxide. So let's go through and name the compounds at the bottom as a little bit of practice. If you're in general, you only have to worry about the stock naming system. If you're in honors, you also need to do the classical naming system. So let's name everything with the stock system first, and then I'll continue with honors to do the classical system if needed. So for SnF2, if you look up Sn, Sn is 10. Let me see where my alignment is. Okay. So Sn is 10. 10 is a transition metal, so we need Roman numerals for the charge, but we don't know what the charge is right now. And F is fluorine, so in a compound, remember we changed the ending to fluoride. There we go. So we have to look at the charge of the fluoride and essentially uncrisscross charges. So if you remember, fluoride has a -1 charge, which would match up with the subscript of 1 that's currently on 10. And then the F, or since there are two fluorides that have a -1 charge, right now there's an overall -2 charge. So if we uncrisscross, that 2 on fluorine came from the charge of 10. So this is going to be 10-2 fluoride. Look at the next example. The SNS2. So we already said that Sn is 10. It is a transition metal, so we need Roman numerals. We just don't know which Roman numerals at this point in time. Excuse me. And S is sulfide. So sulfide has a charge of -2, which means that 10 should have a subscript of 2, but since it does not, that means that this was reduced. So you can't simply just uncrisscross the charges. But since we have sulfur with a charge of -2, and there are 2 of them, that means there's an overall charge of -4. So 10 has to have a charge of +4 to cancel out. So this is 10-4 sulfide. Look at the next one. We have CrN. Cr is chromium. It is a transition metal, so we need Roman numerals. We just don't know which Roman numerals at this point in time. Sorry, there's a delay between my iPad and the smartboard. N is nitrogen, so in a compound that is nitride. Now, right now, both of these have subscripts of 1, so their charges should be equal. If you look, the charge of nitride is -3, so the charge of chromium, for them to cancel out, has to be a +3. So this is chromium 3 nitride. Sorry, 2 of them overlapped each other. You can do the same thing whenever writing the formulas. You're still going to crisscross formulas like any other ionic compound, but you are given the charge of the metal. So iron 3 oxide, remember iron is Fe. Oops. Excuse me, my pen changed in the middle. Fe with a +3 charge. Oxide is O, which has a -2 charge. So if we crisscross our charges, Fe will have a subscript of 2. O will have a subscript of 3. So that is Fe2O3. Last one we have is copper 2 sulfide. So copper is Cu. The 2 means we have a +2 charge. S, or sulfide is S with a -2 charge. And we will crisscross our charges. and those 2's end up canceling out. So it will be CuS once it is reduced. If you're in general, this is the end of the video. Make sure you are practicing your given homework problems. If you're in honors, let's go back and assign the classical system to our ones that have Latin names. So that'll be the first 2 and the last 2. So for the first 2, remember Sn is from stannum. So tin-2 is the smaller charge, so this will be stannous fluoride. Tin-4 is the higher charge, so remember it gets the ending of IC, so that will be stannic fluoride. We didn't have a classical name for chromium, so we'll skip that one. For the iron 3 oxide, remember iron 3 is the higher of the 2 charge, so we'll get the ending of IC, so that will be ferric oxide. The copper 2, remember copper could be a +1 or +2. +2 is the higher of the 2 charges, so that will be cupric sulfide. Make sure that you are doing the practice and tune in tomorrow for a warm-up going through more of the transition metals.